In this video, you're going to learn how we try to make buildings survive an earthquake. Some countries have regular earthquake drills, especially in schools. What do you think that these ask you to do? Do you know why this drill is used? Well, if you are indoors during a tremor, you are most likely to be injured by objects falling on you, especially part of the ceiling or roof. Being under a good table, which is held in place, may save you from these falling objects. It was noticed that some quakes would destroy some buildings and yet leave others close by with little structural damage. The clue was to how buildings respond to the shaking during a seismic event. They have to survive the tremors caused by the P wave and also the S wave, which might arrive quite a time afterwards, as well as the inevitable aftershocks which may last for days or even weeks. Buildings need to give as the seismic waves pass by. Just making a building strong wasn't the answer, since the aftermath of such events showed older buildings might survive when modern ones made with stronger materials didn't. Also, the popularity of high-rise buildings adds new issues, as these will flex more during a tremor than a low-rise one. These also have the additional hazard of raining down glass onto the streets below as they shake. Modern so-called earthquake-proof structures come in different designs, but all have the same objective: allow the building to survive significant side-to-side and up and down motion. They may support the whole building on shock absorbers, or rely on the internal and external skeleton of the building to retain structural integrity, while allowing the building around it to move. No building can be made to perfectly earthquake-proof. The cost would be too high. They are designed to survive the typical magnitude of an event the area might expect over the lifespan of the building. Some features of the earthquake-resistant buildings include mass damper, a weight on top of the roof to detect shaking, cross braces to reinforce floors so they don't collapse, flexible pipes to prevent water and gas leaks, base isolators that act as shock absorbers at the bottom of a building, and active tendon system, which is like a mass damper only on the bottom of the building. In summary, we can build into the design of a building key features that increase the chances it will suffer little damage during an earthquake. All have one thing in common: they allow the building to move within limits and not fail. Look at this picture. Since you now know that buildings are placed on rock or soil foundation, which do you think would provide the best foundation for a building to survive an earthquake? Something you might want to think about after watching this video.